A rectangular house has a volume of x cubed plus 55x squared plus 650x plus 2,000 cubic feet. The height of the house is x plus 5 feet. Find the number of square feet of floor space on the first floor of the house. Disappearing act. So what we have going on here is we're dealing with a house that is the shape of a rectangular prism. A prism is three-dimensional, so our volume is of course three-dimensional. Area, however, is two-dimensional. It is the product of the width of the house and the length of the house. But we don't know those values. But luckily for us, the product of the length and the width with the product of the height, x plus 5, is going to give us the resulting cubic polynomial expression. Dividing the cubic expression, which represents volume, the volume of a rectangular prism is the length of the house multiplied by the width of the house multiplied by the height of the house. They want to know what is the area on the first floor. Area is represented, and they're saying square feet. Square feet is area, which is length times width. So if we divide each side of our equation by h, now we see that the h's on the right-hand side cancel, leaving us with the product of length times width, which happens to be the area denoted A. What does this equal? This equals V divided by h. So the volume of our house divided by the height of our house will give us the area of the first floor for our house. Luckily for us, we have an expression for the volume of the house. We have an expression for the height of the house. So V divided by h, volume divided by height, will be x cubed plus 55x squared plus 650x plus 2,000 divided by x plus 5. Let's see what that looks like. So again, x cubed plus 55x squared plus 650x plus 2,000. This is divided by the height of x plus 5. To divide polynomials, notice we are dividing not by a monomial but a binomial, so we need to use our long division. If you are familiar with synthetic division, make sure and check out the book there. Once we have long division, for any binomial that we divide, for any polynomial that we're dividing with our divisor, we can use long division, so we'll be comfortable with that. For this time purposes now, we will focus on dividing by binomials. Looking at the first term x and the first term x cubed, x will divide into x cubed how many times? X cubed divided by x is x squared. Multiplying x squared to x plus 5, x squared times x is x cubed. X squared times positive 5, positive 5x squared. Division is repeated subtraction, so we will subtract and continue to find a remainder. X cubed minus x cubed is 0x cubed, so they cancel. A positive 55x squared minus a positive 5x squared, well, 55 minus 5 is 50, so here we get 50x squared. Bringing down our next term here, we bring down the plus 650x. Our x will divide into the 50x squared 50 times. 50x squared divided by x is 50, and that is positive. Oh, excuse me. 50x squared divided by x is 50x. Yeah, catch me on that one. 50x squared divided by x. X squared divided by x is x. So we get 50x plus 50x. But now the plus 50x, we will multiply back to the x plus 5 to work on the remainder. 50x times x is 50x squared. Positive 50x times 5. 5 times 5 is 25, so 50 times 5 is 250. Division is repeated subtraction. Subtract to find a remainder. 50x squared minus 50x squared is 0. They cancel out. 650x minus 250x. 650 minus 250 is 400, so we get 400x. Bring down the next term to find the rest of our remainder. 400x plus 2000. How do we divide that with x plus 5? Well, x will divide into 400x 400 times. Because as we see, 400x divided by x, x is canceled, leaving us with the positive 400. (400) times x plus 5. 400 times x is 400x. 400 times 5. 4 times 5 is 20. 400 times 5 is 2000. Division is repeated subtraction, so we subtract to find a remainder. 400x minus 400x is 0. 2000 minus 2000 is 0. Therefore, there is no remainder. And as we see here, x squared plus 50x plus 400 is the area for the first floor of our house. The height, however, is x plus 5. So the length and the width of our house, whatever it is, when you multiply that together, it will give you x squared plus 50x plus 400. And what we will discuss later on is how could we find numbers in such a way that we can factor the x squared plus 50x plus 400, because like as we said, x plus 5, that gives us the dimension for the height of the house. And this is the volume, which is length times width times height. So the length times the width is x squared plus 50x plus 400. To get a jump on this, because we know the area is the length times the width, and that equals the x squared plus 50x plus 400, that means the length times the width is this, which means we should be able to find the factors that equal L and W. What is the length? What is the width? What are the dimensions here? Well, what we need to know is, can we rewrite this trinomial in such a way that we have things multiplying it? As we saw in 5.3, the product of two binomials quite often gave us a trinomial. So my question to you is, what did we have to multiply to get this first term x squared? Well, we had to multiply x times x. So let's begin thinking that in order to multiply two things together to give us a second degree polynomial, we had to have a first degree polynomial times a first degree polynomial, because we know that adding exponents, 1 plus 1 gives us 2. So at some point, a factor of x in one polynomial has to multiply a factor of x in a second polynomial to give us that x squared. Now, what multiplies to give us 400 in such a way that when we combine like terms, it will give us 50x? Well, what two numbers can multiply to give us 400? 1 and 400, 2 and 200, 4 and 100. We have 5 and 80. We have 8 and 50. There are many different numbers, but are any of those numbers able to combine to give us 50? What about 40 and 10? 40 times 10 is 400. 40 plus 10 is 50. 40 is positive. 10 is positive. Notice here the product of these two binomials, x plus 40 and x plus 10, if we FOILed them out, product of the first terms, x and x, is x squared. The outer product is 10x, which is positive. The inner product is 40x, which is positive. That inner and outer product give us that middle term 50x. The last product, 40 and 10, give us the 400. So as we see here, we actually can factor this trinomial into the product of two binomial factors, where one of these is the dimension for length and the other is dimension for width. Now, most often, the dimension for length is longer than width. So we can conclude that x plus 40 is the length of our house. X plus 10 is the width. And as we saw from the beginning, x plus 5 is the height. Number 94 shows that the volume is equal to 2h cubed plus 3h squared plus h. And it shows two of those three dimensions. Remember, volume of a rectangular prism is the length times the width times the height. It's giving us two of those three dimensions, h and h plus 1. To find the third dimension, think of it like this. If we multiply h to the h plus 1 and then multiply that to our third dimension, we will get our volume. To find the third dimension, imagine the formula again. Volume is length times width times height. We need to find one of these dimensions. Let's say here we need to find the length, right? Because it looks like they give us the height of the rectangle and the width. If we divide off the width and the height from each side, then we see here that the length of our rectangular prism is equal to the volume divided by the product of the width and the height. So if we take the volume, 2h cubed plus 3h squared plus h, and divide it by the product of the width and height, multiply h and h plus 1 together, you get h squared plus h. So to find that third dimension, to find the length of our rectangular prism, the length will equal the quotient of the volume and the product of our other two dimensions. Let's go ahead and look here at finding this quotient. H squared divides 2h cubed 2h times. We see that because 2h cubed divided by h squared, the 2 stays. H cubed divided by h squared, 3 minus 2 is 1 factor of h. So we get a 2h there. Two h multiply h squared is 2h cubed. 2h multiply h is 2h squared. Division is repeated subtraction, so we subtract to find a remainder. 2h cubed minus 2h cubed is 0, so they cancel. 3h squared minus a positive 2h squared. Well, again, 3h squared minus 2h squared is 1h squared, or simply h squared. Bring down the remaining term to give us a remainder of h squared plus h. Now notice this, our remainder is h squared plus h. We are dividing by h squared plus h. What do we think h squared plus h divided by h squared plus h is? Any number divided by itself is 1, so we should get a positive 1 here. But the way the algorithm works, we need to work it out. It says take the first term of our remainder, or excuse me, of our divisor, and divide it into the first term of our remainder. So how many times will this h squared go into h squared? Well, again, write it up as h squared divided by h squared. Any number divided by itself is 1, and that is a positive 1. So just to check and make sure that there is a remainder or is not a remainder, positive 1 multiply h squared plus h. 1 times h squared is h squared. 1 times h, that's a positive h. Division is repeated subtraction, so we subtract to see if there's a remainder. H squared minus h squared is 0. H minus h is 0. There is no remainder. Therefore, we see that that third dimension, when we divide, we notice that we are given the volume. We are given two of those three dimensions. To find the third dimension, we multiply together h and h plus 1, and then we divide that into the expression for volume, giving us the third dimension to be 2h plus 1.